Now, moving on to number 3, now we see x and y again. We have both of them, but notice they're on the same side, right? And the only formula we had where x and y were on the same side was our standard form, our standard formula. So we can see here that A is 5, B is 10, and C is 20. Now, what we care about, as soon as we know standard form, guys, we only care about the x-intercept and the y-intercept of this graph. The x-intercept and the y-intercept. The slope we're going to have to figure out from the graph because it's not given to us in the equation. So the x-intercept, guys, we know from our formula is c over a comma 0. Right? The x-intercept always ends with 0. The y-intercept starts with 0. So c over a is 20 over 5, which will give me 4 comma 0. And the y-intercept is 0 comma c over b. So 20 over 10, which gives me 0 comma 2. So I know I have a point on my line at 4, 0, my x-intercept, and 0, 2, my y-intercept. And that's enough information for me to be able to then graph a line, right? So again, let's talk about domain and range. Notice domain, we are going to go, this part of the graph will go to the right forever. This part of the graph will go to the left forever. So my domain is back to being negative infinity to positive infinity. My range is going to go, this side end of the graph will go up forever. This end will go down forever. Nothing, no breaks in between. So the range still is negative infinity to positive infinity. The y-intercept and the x-intercept, guys, are really easy because we already found them with our work in the equation. What's going to take a little more doing here, guys, in this situation is the slope. But if you think back to target 1, if I know what the slope is on my coordinate plane, or if I understand what slope is, rise over run, I can count that from the coordinate plane. So to go from reading left to right, going from this point here to this point, I'm going to go down 2, there's my rise, negative 2, and to the right, 4. So that is a rise of negative 2 over a run of 4, and we can simplify that, right? That can be simplified to negative 1 over 2. So by counting the slope on our graph, guys, we're going to get slope being negative 1/2. So there's an example of standard form. All right, number 4 here, we get another new type of form. Now we have x and y, but they're not on the same side. Y is on the left, x is on the right, but y is not alone. So this can't be slope-intercept form, but this can be point-slope form. Y minus k equals m times x minus h. All right, now this is the one where we've got to be careful about the sign for the values we think of k and h. All right, so when we look here at k, when we look at m, and we look at h, we've got to look to see if the sign changes from what we have in the formula to what we have in the equation. Another way Ms. Custodio talked about in the 4A notes is essentially in point slope form, guys, whatever the constant looks like in the equation, this looks like negative 10, it's actually the opposite. Because the signs stay the same, k is actually 10, and because subtraction changed to addition, h is actually negative 7. Now, the problem we have here with m is, well, there's no number there, right? All we see for m is this negative symbol, but we've got to always remember, if we don't see a number in between the subtraction symbol and the parenthesis, what ninja is actually hiding there? Don't forget about your ninja 1. All right, guys, that's actually, if just having a negative sign is the same thing as having just negative 1. So in this case, m is negative 1, and we would put that over 1. All right, so once we have this, though, we can put h and k together, right? Now, h and k, we've got our slope, but h and k can come together to give us the ordered pair that we're going to use to start that slope. So I'm going to go to 10, negative 7 here. So 10, negative 7, way down here. And I'm going to use the slope of negative 1 over 1. And that's rise over run, so down 1 and right 1, but that won't work. But I can also go up 1 and left 1. So I can just continue going up 1 and left 1, a rise of negative 1, And I can keep doing that. Now, I'll be honest with you guys, the important thing is that you get the X and Y intercept from this. But if you're OCD like me, go ahead and you can just put every point that you want on there, and it will make your line you graph very, very accurate to all of the points in between those maroon points there. All right, and there we go. There's our graph of all the solutions. So let's talk domain and range. Well, we can see again, this goes to the right forever down here, and it's going to go to the left forever up here. So nothing causing a break or a hole in between. So we still have negative infinity to positive infinity. Here we're going to go down forever on this end. Here we're going to go up forever on this end. So we're going to have negative infinity to positive infinity again. We already have our intercepts right here from our graph. You can see 3, 0 on the x-axis and 0, 3. And this can be a little tricky sometimes, guys, especially when they're using the same number but for a different coordinate, are our x and y intercepts. And the slope we already found before in our equation was from -1 there. All right, so that makes things pretty easy. Actually, I'll change this and put this in pink here, right? Just to show us, because we didn't technically get the x and y intercepts from the equation. We got them from the graph there. All right, a couple more here. Y equals 8. So now we only have a y variable. So this is our horizontal formula, right? We know any horizontal line, the slope is 0. That's what happens every time we deal with a horizontal situation, horizontal. And what we see is that k is equal to 8. Well, what that tells me about the points on my line is that every single point will have the same y coordinate of +8. I can put any number I want in here for the x coordinate, it doesn't matter. I find it easiest just to put 0 in there and go with the y intercept. But you technically could put any point you want. So let's graph our point here. 0, 8 is right here. And again, this is the same thing with the vertical line. I don't need any other points. If I know it's horizontal, I know it has to follow perfectly to the left and the right of 0, 8. All right, now let's talk about domain. Domain here, pretty easy. Clearly, this is going to go to the right forever, and this is going to go to the left forever. This is kind of the most obvious domain situation here. But the range is what gets a little tricky, right? So it's going to go up, and 8 is the largest number that I'm ever going to get vertically, but 8 is also the smallest number. Again, we can't have an interval between 8 and 8. They're the same number. So very similar to what happened here, where the domain was just a number and the range was from -infinity to infinity for a vertical line. When we flip the line from vertical to horizontal, we flip kind of what we have with the domain and range. Now, the domain goes from -infinity to infinity, and it's the range that is just a single number. All right, we do definitely have a y-intercept here. We found that to be 0, 8. Now, the question is, when will this green horizontal line ever cross the x-axis? And guys, the answer pretty hopefully obviously is it won't. It never will. So what this tells me is there is no x-intercept. All right, just the same way for a vertical line, there was no y-intercept. All right, my rate of change, my slope, we already found that from just knowing this is a horizontal line is m equals 0. So we just did an example of using each type of the formula. Slope-intercept form in number 1, vertical form in number 2, standard form in number 3, point-slope form in number 4, and horizontal form in number 5. Now, this last one here is a little bit tricky, and we put this in here for a reason, just to make sure you're aware. It is very easy to look at 5 and 6 and think they're the same. There's a lot the same. They both have y alone. They're both equal to 8, but there is a huge difference that this is equal to 8x, down here, sorry, 8x, and this is just 8. There are 2 variables. If there's 2 variables and y is alone, the only formula we know that works with this is slope-intercept form. Now, the reason this is confusing is because we don't see a constant in our equation. Well, there is a constant there. It's another type of ninja. It's the ninja term. It's not a ninja coefficient or a ninja factor, which is 1. It's the ninja term, +0. Anytime a formula has a constant, which you don't see represented in the equation, that's because that value is 0. So guys, anytime you see a y and an x, but no constant, I would recommend writing in this +0 because that's going to help you avoid making some mistakes when you start working with your graph here. It's very easy to think 5 and 6 are really the same problem when they're actually, you're going to see very, very different. All right, so we see here that my slope is 8, or we'll think of it as 8/1 for graphing, and b is equal to 0, which gives me a y-intercept of 0, 0. All right, so now really number 6 is just like number 1. We have our y-intercept, which is 0, 0. I have a slope of 8/1, so I'm going to go up 8 and right 1, and that's all I can do. I can go down 8 and left 1, and that's all I can do. And so now, let me just use those points. These were the only points I could fit on the coordinate plane, and boom, there is my line representing the solutions to this equation. All right, it's very similar. The domain is still going to be -infinity to infinity. The range is still going to be -infinity to infinity. And this actually just made our lives a lot easier with our x and y intercepts, because where this graph crosses the x-intercept is exactly the same point it crosses the y-intercept, right? We see, sorry, let me just change colors here so this stands out a little bit more. We see here, guys, that this is the x-intercept and it's also the y-intercept, and that's fine. The origin is a special point. That's why it gets its own name, and no other point gets called a special name, because it's both the x and y-intercept at the same time in this graph here. Our rate of change, we already found that from our equation, was 8. And there we go. That's what we'd get. All right. So I just worked through 6 examples here, going through all the different types of formulas that we're going to see. If you got questions, again, guys, please hit up Miss Custodio, hit up myself, send us an email, send us a message in Schoology, go into ClassKick, go into the worksheets, ask us questions. But this is going to be such important stuff. You're going to see this in geometry. Geometry is going to bring back these algebra equations, and it'll be hugely important in a couple of years when you're in Algebra 2 and AAT. You're really going to need to be able to work with formulas, comparing them to equations, to pull out information, to graph and work with our characteristics. All right, that's what we got. So we would love to hear from you. We want to know how life is going, but also want to be able to help you out with math. So hopefully we'll talk soon.